Okay, we have here today another integral. This one's from MIT Integration Bee 2025, number 17. We have the integral of sine x times sinh x dx. Now, of course, you could do integration by parts on it, and it would go pretty quick. Not too bad, but it's kind of boring. So what I wanted to do instead was use the complex method on it, and what we'll need is just a few definitions before we start with it. Okay, so first, over here to the right, we've got our definition for sinh. We'll just be using this. We'll plug this in here in a little bit. Then next, here we have Euler's formula. The reason I want this is because if you think about this as a complex number in the form like a plus bi, if we take the imaginary part of this, it's just going to be the b on here, which is just going to be sine x. So what that's going to allow me to do is plug in for this value for sine x here in the integral, just keeping in mind that we need to remember when we come back in the end, it's going to be just the imaginary part, but we can really just plug in this. So how we can rewrite this is we can say we want the imaginary part of this whole integral, plug in EIX for sine, and get our definition for sinh e to the x minus e minus x over 2. And then we'll go ahead and simplify this. I'll probably forget the imaginary part at some point, but we're going to need, in the end, we're going to need it in order to solve it. But I could take this half out as a constant, I think. I think that's the way to go. Then distributing this into each term, we're going to have ei plus 1 x minus ei minus 1 x dx. And then from here, we can really just integrate it with no problem. Don't get too worried about this. Just think about this as a constant. You could substitute it or whatever. Just dealing with that like any constant. What's going to happen? We still have our half out front. This is going to be ei plus 1 x over I plus 1 minus, same kind of thing over here, I minus 1 x over I minus 1. But let's take this minus sign and use it to reverse the sign over here. So I can kind of do this. I'll just flip the order to make it clear that we want this now to be 1 minus I. Then next, I'll get a common denominator, multiply in 1 minus I here. Same kind of thing over here, multiply in 1 plus I, 1 plus I. But now this is going to be pretty nice because when you multiply this out, let's see what happens. You're going to end up with 1 minus I squared, but I squared is minus 1. So this thing is just going to be a 2. So when I rewrite this, we can put this whole thing over 2. One other thing I'm going to do is notice we're going to have an EIX in common. If we put this, like for EI plus 1, we can put it back and write it as EIX times e to the x. And then the other one, this one's going to be EIX e minus x. So I can just factor this out in front. So what I'll do is we'll have EIX over 2. Everything left is going to be over a big 2. And then with everything else, I'm going to distribute it out. So we're going to get like an EX times 1 minus I from this term, EX. Here we're going to have an E minus X times a 1. So we're going to have plus E minus X and then plus I E minus X. And I'm going to need some space. Let me clean it up and we'll just try to simplify this thing and see if we can finish it. Okay, now from here, we're in pretty good shape. I actually just kind of want to reorder this whole mess in the numerator. Let's group the ones that we have just, like the ones with the I in front, with the I coefficient, and then group these. So we'll group this one and this one, and then we'll group this one with this one. So how it's going to look when we do it, we still have this EIX in front here. Then grouping the blue stuff, we're going to have e to the x plus e minus x over 2. For these red ones, I'm actually going to reverse the sign. Just you'll see why in a second. We'll take a minus out front, and then that way this becomes a plus on this one. And we'll also factor an I out front like this. So then here we're going to have e to the x. This is going to become minus e minus x all over 2. But what we have right here, this is the definition we saw before. This is just sinh of x. And then over on this one, it's only differing by the sign. I didn't have it written down before, but this is the definition for cos x. And then one more definition. This is what we had before. This is what we had before. Again, we can put it back with Euler's formula and write this as cosine x plus I sine of x. So let me rewrite all that, but we still have this 2 here, so it's all going to be over 2. So we have Euler's formula, and this is going to become just cosh x minus I sinh x, and this is all over 2. So then I can just FOIL all this stuff out, and let's see what we have. And now we're pretty much at the end, because I reordered this after FOILing it out so that everything over here, this is like a complex number, where everything here is going to be real. This will just consider this like a and plus our bi. So the imaginary part, what's going to happen is the whole real part, that goes away. We also don't worry about I. We just want the imaginary part, which is going to be all this. So for my final solution on it, we just get sine x, cosh x minus cos x, sinh x over 2, add a plus c, and that's it. Okay, there you go, MIT 2025. Thanks everyone for watching. Have a good day.